All right, today we're diving into something pretty wild, a radical new scientific theory that's trying to literally map the inside of your mind. And we're not talking philosophy here, we're talking about the actual geometry of your consciousness.
So, let me just start with a huge question. What does the inside of your mind actually look like? Seriously, take a moment. What's the landscape of your thoughts, your feelings, your perceptions?
And just to be clear, I'm not talking about the physical brain here, that 3-pound chunk of tissue with all its neurons and wires. I'm talking about your subjective first-person experience. You know, the feeling of warmth from the sun, the taste of your morning coffee, the sound of a song you love. What's the shape of that? Now, that sounds like a question for a philosophy class, right? But what's so incredible is that a new scientific theory is proposing a concrete answer. It's suggesting that our consciousness, our inner world, actually has a specific, measurable, geometric shape.
Okay, so this whole idea is called the phenomenal manifold hypothesis. And at its heart, it's pretty straightforward. It proposes that we can create a literal map of the mind, a geometric space that represents every single possible experience you could ever have.
So what in the world is a phenomenal manifold? Well, put simply, it's a mathematical space, kind of like a map, that contains a specific location for every conscious experience possible. It is the complete, total landscape of your inner world.
So on this map, right, every single point is one unique, indivisible moment of experience. Think about seeing the color red, just pure red. Boom. That's a single coordinate, one tiny dot on this enormous map of the mind.
And, just like on any good map, distance actually means something. Points that are close together represent experiences that are really similar. So the point for red would be right next door to the point for orange, but it would be miles and miles away from the point for, say, the sound of a trumpet.
So if you put all those points together, every sight, every sound, every thought, every feeling, you get the complete landscape. That entire geometric space is the phenomenal manifold. But what decides its shape?
Well, according to this theory, the shape of the map isn't random at all. It's sculpted by 3 key properties of your brain's activity that we can actually measure. You can think of them as the rules of cartography for your own consciousness.
These 3 rules, or forces, are called integration, coherence, and differentiation. So let's just break down what each one of them means for the actual shape of your experience.
First up, we've got integration. This is all about how unified your conscious experience is at any given moment. When you watch a movie, you don't experience separate pictures and hear separate sounds, right? You get one single whole experience. That's high integration, a unified conscious field.
Next, there's coherence. This one's about how synchronized the electrical activity is across your entire brain. Just think of it like the brain's overall rhythm. Is everything just firing off chaotically, or is there a steady, synchronized hum across the whole system?
And finally, differentiation. This is all about richness and complexity. It's basically a measure of how many different conscious states you could possibly be in at any one time. A highly differentiated mind is having a really rich, detailed, and complex experience.
So here's where it gets really cool. When you combine these 3 forces, integration, coherence, and differentiation, you get these dramatically different shapes for your inner world depending on your state of consciousness. This is where we can actually start to visualize what that map looks like.
Let's just look at a super clear contrast. When you're awake, your experience is rich and unified. That's high integration and high differentiation. But in a deep, dreamless sleep, all 3 of those measures just plummet. Your consciousness isn't simply off. Its entire geometric structure has basically collapsed in on itself.
And this table really brings it all home. Wakefulness, like we saw, has a huge, high-dimensional map. Deep sleep is collapsed, almost nothing there. But look at the others. A psychedelic state might cause the map's volume and complexity to just explode, an incredibly rich experience. On the flip side, deep meditation might actually contract the map, simplifying it into a really coherent, low-dimensional state of just pure awareness.
Now, this all might sound like a really fascinating metaphor, but here's the most powerful part of the phenomenal manifold hypothesis. It is a real, testable scientific theory. It makes concrete predictions that can be proven right, or, and this is just as important, proven wrong.
And this is what makes it real science. The authors are incredibly clear about how their theory could fail.
For example, if it turns out the basic map is wildly different for every single person, or if those 3 rules aren't actually independent variables, the theory falls apart. That's what makes it so scientifically rigorous.
It also makes unique predictions that pit it against other big theories. For example, a major competitor is called Integrated Information Theory, or IIT. IIT says high integration is pretty much all you need for consciousness. But this new hypothesis predicts that if you have high integration without coherence, your experience would actually be a rich but totally fragmented, chaotic mess, not a unified conscious state at all. It's a clear, head-to-head showdown between theories that we can actually test.
So, let's just say this theory holds up. What does it actually mean for us, for the future? The implications of successfully mapping the geometry of our consciousness are, well, they're absolutely profound. They touch everything from medicine to artificial intelligence.
I mean, just imagine being able to objectively measure the shape of consciousness in a patient in a coma to see if anyone is in there, or being able to perfectly track the collapse of the map to know the exact depth of anesthesia during an operation. We could have geometric biomarkers for mental health conditions and even a principled mathematical way to ask one of the biggest questions in technology: is this AI conscious?
And that really leads us to the final mind-bending thought. This research gives us a potential recipe, a set of criteria that create a specific geometric structure. So if we build an artificial system that displays the exact same informational dynamics, the same geometric map, have we created consciousness? It's a question that used to be science fiction, but we might actually be getting the tools to answer it.